What am I looking for? Oh, yeah. Nope. No, definitely not that. Right, so I'm trying to get this thingy to work, which is a program someone wrote for Ludwig, which supposedly, okay, it's a bit too loud, which will supposedly like update the thumbnail of the YouTube video every 3 minutes. However, it doesn't seem to work. Well, for one, you know, it's supposed to be a Windows only program. I'm on a Mac. But it is just written in Python, so I was running it. I just ran it with Python. It seemed to work. But it threw some error. And I wonder why. Because it's not extremely enlightening. This says error with API call. I think, what I think it might be is that I might just not be able to edit my thumbnail at all. Which is a really weird choice if you want people to get, you know, I don't know, could become popular on your streaming service if you don't allow them to edit thumbnail if they are little losers like me. Let's see, YouTube live stream edit thumbnail. How to change your YouTube Alright, I'll watch this YouTube video. Just show me where it is. Okay, you need to do it in YouTube Studio, okay. Content. No, live content. Yes. Here I am. Edit. Oh yeah, now I can upload a thumbnail. Yeah, no, that should be possible, so it's not that. The API also did give me an error that I wasn't able to add myself as a test user. for the app that I'm making, which seems weird. Like, I feel like obviously, you know, you'd want to be able to test things yourself. Whoops. So I just go this way. I don't want small screen. Okay, whatever. Maybe let's try this again then. I do need to figure this out quickly, because otherwise I will just get stun locked on this all day. And I can't really show you this, because otherwise you see all the fucking stuff. I don't want that. All the credentials. Did I have an authentication yet? Oh. No. Okay. Edit app, yeah, that's what I want to do. I want the sunscreen. Okay. Scopes. Yeah. Uploads and okay, add a test user. Add myself. Add. Okay, save and continue. Does it say the warning again? Okay, the following email addresses are either not associated with the Google account, or the account is not eligible for destination as test user. Why? How are you guys doing? I asked if someone is watching. Whatever. Okay, I'll just take a screenshot of OBS and live with it. Know what I want to do, but I'll figure this out later. Let me go to this stream. Oh, is the bitrate that horrendous? Oh no. Fuck up. Okay, I need to just make a really good fog face for a second. Wrong, I'm facing the wrong fucking side. You can't see my face if I do that. thumbnail somewhere. Okay. Once again. Once more with feeling. Come on, meat. Perfect. Probably make that part bigger, but whatever. It's a thumbnail. Better than no thumbnail. Now it's just my like dark, like very dark picture of my face. Okay. Don't stream video and stream video at the same time. Upload thumbnail. Document, or did it go? Yeah. Perfect. Hello, first time chatter. Oh bro, you look so ugly with that nerd face. Yeah man, I was doing fucking thumbnail faces. Or are you just talking about my normal face, in which case you're extremely cringe. Oh, that is very funny. Can I ban you from here? It'll be fun. The first time banning someone. Nah, I think I need to get into this for now. I wanna do it. You will feel so... Thank you for listening. Some fucking fun. Thank you for listening. Some fucking fun. Thank you for listening. Hell yeah. First ban. I'm a real fucking Twitch streamer. Have fun. Gonna tell my fucking friends about it. Because I have better things to do. Alright. Get rid of this. Oh, don't get rid of the music. But maybe we can do one different song. Boys! So, welcome back. What did we do last time? I need to put this thing into the fire, otherwise I'm gonna bring Crouch to talk to it the whole time. So, last time, this music is too fucking hype. I just need to have, like, I just need my lo-fi girl. Yes, that's better. Alright, so, last time, what did we do last time? So on the stream, I do this in order to work on my fucking thesis. So you saw that last time, that was more than a fucking week ago. And so we need to like kind of recap what the fuck we did again, and then I guess make a plan for what we were gonna do this time. So can I do this like here? Okay, so create new file. It is. We did just animal day today. So it's a good time to go vegan if you haven't already. Alright, so last time. Okay, this music is definitely too loud. Okay, that changed the sound for you, not for me. Okay, now that changed the sound for me. So last time we mostly focused on my website, which wasn't extremely useful. Wasn't really what the point was of the of the stream. Does not really work on my thesis. But I don't know. We went through it, saw what what's on there and what I kind of wanted it to be and what it is not. I took some tips from it for what to do, what to change about it, and mostly that was to make it. I just need to talk about this for a bit in order to get in the mood of talking. To make the main problem was trying to really fit this kind of static site generation onto a website that isn't that static. I mean, it is pretty static, but all the things that I want to do with it aren't very static. And also, well, the more that I think about it, I think the problems are more with how Next.js does things with static site generation rather than the problem with it being static sites. Let's just do that for a bit in order to get into it. You know, I like doing this. Let me just get a new tab up in here. Yes. I can't show you code because I have like all my coding things blocked for once, which is good, but yeah. So yeah, the problem is like are these things, like when you hover, okay, see, you can already see why it doesn't work. When you hover, you get these cards. Those are cool, but they have to kind of get fetched from someplace, or you have to load all of them in with the site and have to load in the rendering mechanism, or you have to load in all the rendered versions of them, which would, both of those would make the site really quite big. Probably if I were to do that, I would just load in the rendering mechanism and then all these things as like text, because otherwise it would just be too big. But I didn't want to do that. I want to kind of to optimize it. And so what happens now is that I send a request to the backend, to like no, not really a backend, like a serverless function, which renders this card and then sends back the HTML. Well, okay, like something that looks like the HTML, and shows it to me here, which works. The problem is, where does the like serverless function get the HTML from, or the markdown file from? Because I didn't want to interact with any outside API, because then you have to have some other dependency, which is problematic. And so instead, in a moment of genius, I just thought, oh, what if we just put all these things in the public folder, and then the serverless function can fetch that from the public folder, yada yada. Now, it turns out this is a really stupid idea, because the public folder only changes at build time. This in itself is sort of okay, because you know, it's a static site, so you build it every single time. Well, but the problem is that this method of doing things is just extremely messy. You need to do like a lot of like modifications. You need to like use isomorphic Git to clone the repo into the public folder at build time, which is really stupid way to do that. And I need to do that because, well, I don't need to do that, but I want to do that because I don't want the package for the website to be kind of a separate thing from the package for the content, so to say. So it could probably be done differently, but that's how I chose to do it, which is a decision. But yeah, so the problem with that is that ideally I don't want to re-render the whole fucking website every single time the content changes, because it's very easy, I have noticed, because it's rendering MDX, for it to crash and not render something. And I don't know why, I haven't figured out for a way for Next.js to kind of ignore those renders, for it to just say, this thing failed, yeah, I'll just throw up a 404 page instead. But no, it just fails the build, which I think is a good default behavior, but it shouldn't be the only possible behavior. So now instead you just don't get anything. So then I thought, okay, well, it would be easier to just server-side render it from the content of the Git repo that it is pulling from anyway. But then the way I spent so long in this mindset of like, oh, I have to do everything this stupid static way, that all those methods, which, you know, involves also creating like an index, which is saved also in the public folder, which the serverless function then pulls from in order to find which fucking file you need to use. It's really stupid. Yeah, that doesn't work with the serverless or the server rendered version at all, because you need to like pull in because the whole website is only built when the website changes, not when the content changes. I guess I could also let it build when the content changes, but that defeats the whole purpose of having it being server rendered. Like, it saves no extra, I don't know, it just feels like a bit of a waste to do it like that. To have server rendered pages and have it rebuild the whole website. That's just silly. Good work, but whatever. It is just extremely clunky. It is really hard to, it's really not very, because you're doing a lot of file system stuff, it's hard to keep track of what has happened, you lose type safety. It's really not ideal. So instead, in the new version that I was working on, I just pull everything from GitHub immediately and just work with the GitHub API directly. I didn't want to do that because I didn't really know how to do that without going over the rate limits. But now I just, okay, I'll use like a, what do you call it? Redis buffer in between in order to save on calls. And the main call that is difficult to, you know, that will need to be done the whole time is like this thing, because I need to read the contents of the Git repo. I can't do that I can't do that every single time, because this is, I think, one call, but if you need to do that, you only get 5,000 calls an hour. Not that 5,000 people will visit my website, but it's, I think every single time you click on a link, it will still do the re-render. So it's just not worth it. It's not worth it. Also, there's just a lot of fucking wasted bandwidth, because this is like quite a lot of data if you also consider all the sorting shit, etc. So not worth it. And what is nice is that actually working with the GitHub API frees up the possibility of also easily displaying diffs, etc. I didn't do that before because, well, okay, so I did do that, like if you can see here. I don't know, it doesn't work anymore. Like if you go here, it crashes. I think I actually statically rendered all these things at first as well, which is also not very smart. Yeah, so this doesn't even work anymore. But at first there was this way of viewing these diffs. Is it still? No, okay. So nothing works. It also only shows the latest one. It shows the. Okay. Because where does it go? Where am I? I'm only at like. It should be something / something, but I'm only at 1. Oh, because I'm not comparing it. Okay, let's see. So here, like this, you could compare it. It's not very useful UI. Okay, well, it doesn't really work, but it used to work. But the way that I did that was extremely different, like extremely stupid. Like on the back end, I actually re-rendered all my fucking yeah, I just re-rendered, like I did all the git diffs myself for every single, like from everything until main. So from here to main, from there to main, or between, no, between every single one, never mind. Like from here to here, if you then looked at this file, you could see what had changed between this version and this version, which worked. It did actually work. It didn't work really great because the diffing mechanism didn't play very, like how I implemented it didn't play very well with the rendering mechanism, but in the end it did sort of show you something. The problem is that you could only view it here. There wasn't really a clear way to link to it. Okay, no, there was also a link to it from the Thesis thing. But that, yeah, it wasn't really ideal. And so what I would like to do is integrate that more with how you actually interact with the website. So when you click here, you could see, I don't want to do that by default, I think, to just save on API rates, see the history of the file. Yeah, and then I also need to, and then ideally you could click through it and then it would change here. And I, like doing that with my fucking API, that was extremely difficult. It wasn't very nice. Doing it with the GitHub API, that would be a lot more easy because I can just fetch those diffs directly from GitHub. They can do the diffing for me. And then I could just like browse through it and click show the diffs. Very nice. Very nice. The problem with it, are there any problems with it? Yeah, so the problem is the caching and the rate limits, but you know, every single time I fetch one, I just cache it, and eventually, you know, I will just have enough cache that will be no problem. So I think that's how I want to do it. And I also want to get rid of my own like hacky implementation of this comment system. It's not my implementation. I just stole it, but I kind of tweaked it a little bit to have custom rendering and have allow for you to view private repos. But I think like the rendering, like the latex shit, GitHub now also does natively. So I could indeed just do that from here, from the preview, and use the token from the user, so that doesn't get rid of everything. Doesn't make my API slower, or like doesn't count to my rate limit. Yeah. And ideally I would also show a better interactive overview than just this graph and then this. Like, who the hell? No one will look through here. I want to maybe show it in a like horizontal way. Anyway, that's it. Okay, so this doesn't work anymore either. I think it's just because this token is expired. This is provide anything useful? Nah, I need to look at that link also. Okay, so that was that's that. So that's what we did. That's what we did. Then we did a little look into what idealizations are. I can't really remember exactly what we did, but I think we just went over like, okay, what is, and basically we just went over Shaq's paper really briefly, not in a lot of detail, but in some detail. Yeah, we just kind of went through the main points, then looked at what the fractional quantum Hall effect is a little bit, and I noticed like, ooh, it is kind of hard. And then we stopped because it was like 3 hours. So, what is cool is that I actually wrote down some shit to do. So, I wrote down here that I can liken the ball space, which is the... I think I should show that image before. Split it up again. I need to have, oh, I have it here. Yeah, this. So this represents the possible configurations of 2 electrons in the fractional quantum Hall system. And basically this is, I think, a valid configuration space if you assume that, assume that, yeah, is it assume or is it assume? I think it's assume, right? Assume. If you assume that the electrons can have to be at like a certain radius from each other, maximally. Like they can't have, like, definitely because of the Pauli exclusion principle, but also just like practically, they cannot come infinitely close to each other. That would require an infinite amount of energy. But they can. The problem is, I think they can get arbitrarily close to each other, but not all the time. Like they have to have. I don't know. That's like still something to work out. It's a big thing to have to work out. The other thing is, and this box then represents the geometry of the of the fractional quantum Hall system. This is kind of the plate where they are allowed to be in. Obviously, it shouldn't be just like a block, but it should be somewhat segmented because it's only a few atoms thick. But there, yeah, and so if you have both of these, if the height or any dimension of the block is smaller than the distance they can be from each other, or allowed to be from each other, there is this kind of this sphere of like excluded possibilities protrudes out of the block of allowed possibilities. I should color those differently because now it seems like, oh, they're both allowed. No, this is like not allowed. I should actually just remove it instead of like adding it. Silly Billy. But the spherical shape does make it more clear that it is what it is. If you just remove it, then it just seems like there's a hole in there. But that is the point. There is a hole, which makes a space multiply connected, which allows for all the wacky Annian stuff. I think that is what I want to do today. I want to go over the arguments for why multiply connectedness leads to Annians, leads to fractional quantum Hall effect. Because that is not trivial, and I could really use the refresher. And then I should really either work this out or just also refresh this. So I can liken ball space to the heap paradox vagueness. Normally infinite idealizations are hard to liken because there's no clear boundary point you need to cross. Normally you only reach it. With ball space there's a space in 3D where there is multiple connectedness, and you can manipulate space to get to the problem region. You can also very easily do this with phase transitions. There's a clear point where transition. I was just so hyper-focused on the number of particles that I did not look at temperature for the relevant quantity. Yeah. Contra the heap, we can define a specific critical point. Our problem is not with understanding 2D-ness or phase, as it is with the heap. Counterpoint, maybe we don't understand phase or dimensionalities as well as we think. Just like with the heap, we understand grains, we just don't understand behavior, we understand temperature height, we just don't understand phase. This is just make point, hey, similar, how interesting, someone should look into this more, Lamau. Yes, so here I want to, I said this because I want to like make this kind of similar to liken the these problems, these infinite idealizations, to problems that are called the Sorites paradox. Do I have like a how do I search like files in here? Hotkeys. Search in all files is Command Shift F. Files. File to another folder. That's pretty useful. What is a useful command for that? Command Shift M. Is that already something? Oops. Command Shift M. 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 Oh, Command Shift M is already something. It is. I have that set to join meeting, and now it opens fucking Microsoft Teams. Right, how about straight up mountain? Okay, cool. So I need to do that with this. This needs to go to streams. Voila. Okay. I still need to. I still want a way to just like search through all the files. Not like just by title, not by content. Is there another way to do that? What do I want? What do I want to look for? Sorites. Really? No, okay, so it's just not working. Searching just doesn't work? What? Yeah, okay, I guess a quick switcher is what I want. Quick quick switcher. This is Command O. I don't like it. I want Command palette to be Command Shift B. I want quick switcher to just be Command P. Okay, yeah, I do have a file for the Sorites paradox. So the Sorites paradox, it is Greek for heap, is a paradox showing the problem of delineating vague terms. We agree that 100,000 grains of rice, it's always grains of rice, which is not very useful, because some people do have, because A, it is very discrete, and B, some people do have intuitions about when is something not a heap. So maybe the better way to do it is like, we think someone is tall if they're like 7 feet tall, and we think someone is not tall if they are 3 feet tall. So, and let's just, you know, imagine like we're talking like about an adult human. I think no one thinks a 3-foot person is tall in any culture. Then, so 3-foot person is not tall, 7-foot person is tall. So let's imagine otherwise, maybe the 3-foot person is a child, and maybe they, like every day, or like every unit of time, whatever, they grow a millimeter. So today they are a millimeter, like 3 foot, 0 millimeter. Okay, let's stop the 3 foot shit. Let's just start with 1 meter. It's like from 1 meter to 2 meters. So first they're 1 meter and 1 millimeter, then they're 1 millimeter and 2 millimeters, and then over the course of 3 years, they grow to become 2 meters because they grow a millimeter a day. So we would say if they are a meter, then if they're 1 meter and 1 millimeter, they're still short. If they are short already. If they are 1 meter 20 and they grow a millimeter, then they are still short. Similarly, if they're 2 meters and they shrink 1 millimeter, like they are 1 meter 999 millimeters, then they're still tall. Like you wouldn't say, oh no, that is the exact bar for tallness. Similarly, if they shrink 1 millimeter again, they're still tall. Now, the problem is that this is you can make this problem with this, the inductive Sorites. 1 grain of rice does not make a heap. A 1 meter tall person is not a short person. But what similarly counts, if a person of n meters tall is not tall, then adding or subtracting a millimeter does not change their tallness. Therefore, this logically follows that there isn't a set length that makes someone where adding or subtracting a millimeter makes one tall or not. And this is obviously unacceptable. Because this is more strongly. There does not exist a number n grains of rice that make a heap. So this would mean if a person is 1 meter and you add a millimeter, it doesn't make him tall. This intuitively is the case for every length. So if they're 1 meter 30 and you add a millimeter, they're still not tall because of that 1 millimeter. So you can, like, by induction think like, okay, for every n millimeters that someone is tall, adding a single millimeter does not change whether they are tall or not. And so if that is the case, you can just keep adding millimeters, and that would become your new n. So by logical induction, mathematical induction, there does not exist a length n of millimeters that makes someone tall, which is obviously not false, because we previously concluded that someone who is 2 meters is tall. That is a thing. So now we can do it the other way around. So okay, let's stop this. We can go from the other point. So someone who is 2 meters tall is tall, and let's say we don't like this assumption, the conclusion of the last argument. So we say it is not the case that for all n grains, for all lengths n, someone is tall. So we start with 2 meter person, and we say, okay, it is not true that every single length n is tall, because that's not true. So what follows is that there is a length n where adding or subtracting a millimeter defines whether they are tall or not. So this is the line drawing argument. And this is, well, in contrast to the above, like here. There does not exist an n number of grains of rice that make a heap, or that this goes against this, and this goes against this. So both of them can't be true at the same time, but they do seem, some of it does seem true. So what do we do with it? And basically what do we do with it is the whole study of vagueness in philosophy of language. So how can we still talk about there being like two ends to some continuum while not accepting both of these premises? Because if we do, then we have a logical contradiction, and that's not nice if you have a contradiction, because then you can prove anything, and we don't want to prove everything. That's a bit too much. We want to prove only the things that we think are kind of right. So what do we do with it? So I think there are a couple of, well, okay, I don't think, like, so there's a couple of ways to solve this very philosophy of language-y, which is to, you know, say, okay, well, maybe there is this like vague region in between, but we do understand the regions at the edge. It's just like at some point in the middle, or you get kind of confused. Yeah, I don't really like that, because then you are sort of drawing a line between the vague regions and the non-vague regions, which then you get like higher order vagueness, which is really, really annoying. So you're like, oh, we're vague about being vague. And if you're at that point, then I feel like you should just give up and like either accept I don't care or do something else. The other thing that you can do when like I think you can do when like confronted with these kinds of examples is you can because you do need to resolve it in some way, which is usually to say like the pragmatic solution, which is just I don't care, but if you do care, you can also say, okay, maybe one of these two terms isn't, like our idea of those things isn't what we thought it was. Maybe one of these two is not, yeah, I don't know, like maybe we can accept this conclusion. There does not exist a number n grains of rice that make a heap. So maybe we can say, okay, well there are no heaps. Heaps are just a figment of our language, and basically, and then you say we don't care. So we don't care about heaps, and then we stop talking about heaps. Such a similar argument you can also often make. This is kind of what got me into philosophy, kind of this deconstructing these binaries in a way, with gender. So if you have, it goes a bit differently, because you don't just like add like a quantity to something and make someone more of a gender, but it is kind of like that. Basically what you do is like you think about like, okay, what aspects of some of a person makes them more like a certain gender. So like if you very naively think about this and you think that gender is sex, you think, okay, maybe having a womb is like, no, people always do this from the perspective of like what makes someone a woman. Like, it's boring, let's do it for men. So having a penis makes someone a man. So okay, what if someone is like castrated or something? Does that not make them a man? Well, probably not. What if they like lost half of their body in a car crash? Does that make them not a man anymore? We probably wouldn't say so. Okay, maybe it is being able to produce testosterone. Well, women also produce testosterone. Everyone produces testosterone. And if you, I don't know, get rid of your balls, then you produce a lot less testosterone. And you need testosterone replacement therapy like trans men do, you know? So it's not very different. No, I don't think so either. So that does not like fundamentally make a man like the amount of levels of testosterone that you're naturally being able to produce. And so on and so forth. You go like, so I guess like the scale here is how much traditionally masculine traits does it take to make someone a man. So we think obviously someone who's like, I'm a man, who says they're a man, and who is, I don't know, you know, like fucking lumberjack kind of guy. You're like, oh yeah, that's a man. That's a man. He says like, oh, I'm a man. Yeah. And they look at, I don't know, a woman, and they don't look like a lumberjack, and they're like, I'm a woman. And they're like, okay, now that's a woman. Yeah. And you look, okay, so what does makes them, so they're kind of pretty different. What makes them different? Well, okay, you go through all these things, like, it's really none of these things. Like, I can add a lot of these things, but it still doesn't really make someone like, you can find exceptions to the, I don't know, of like adding one of those features or subtracting one of those features and still saying, no, that person is still a man. And if you do that, like in gender, I think you're only left with people saying, I'm a man or I'm a woman. Like there really isn't that much else that you can draw these lines by, unless you go for the like, and this is also this is a possibility, where you go like, oh, now you need to have a certain number of these things. Like say, I don't know, we have like a list of like all stereotypical, I don't know, woman stuff. And the only thing that is then more masculine is that she produces way more testosterone, maybe like on the level of average man. Then would you then, where we go? Then you would probably still, I don't know, if you look at like a very good female athlete or something, you'd probably still say like, okay, that's still a woman. It doesn't really matter. If they had like, I don't know, almost everything, then, and if like not think about self-identity, which is whatever, then maybe you could then still then say, okay, now at that point they're a man. But that gets very, I think it's very difficult, because you need to have like, then define which number of things is enough to categorize someone. It is basically in a way I need to remember what they call that. Hyper realism? It is. I don't think that's a very good way of doing it. So in that way, that is kind of similar. And like, so then either you can go like, okay, so if you think self-identity is, I don't know, like a extremely relevant part for what gender denotes, then you can say, okay, self-identity is the only thing that is relevant for gender, because that's I gotta guess the only thing that then differs between men and women consistently. Or you can say, okay, so there is actually no scale that we're measuring. There is no men and women scale. There's just like, I don't know, stuff and people. And they sort of place themselves along these things with... obviously there are variations between most men and most women. But it is... And just like there are a lot of differences between a heap and not a heap, but it is then difficult to say what exactly makes it. And so what you can do, and I kind of like doing it, is and say, okay, then there is no underlying thing that we're measuring. It is just like we kind of made a guess at first, and then we realized, maybe it doesn't really work. The problem is that you can do this with literally everything, and you find that literally every single term that we use is vague. Like, I don't know, mouse. Like this, I have this vertical mouse. It's kind of different than the normal horizontal one. So you think like vertical orientation is very important for mouseness? Meh. I don't think that would really make a difference. Is it like two clicky things? You know, I think the trackpad you could arguably say is also a mouse. It doesn't have two clicky things like my MacBook doesn't. Is it like a thing that moves the pointer on a screen? Well, you can also do that with your keyboard. If you have like, I can do that right now with my keyboard. Like, ooh, I'm using my keyboard to do this. Is my keyboard a mouse? Okay, maybe it is. You have to translate some movement into movement on the screen. Okay, is then the Microsoft Kinect, is that a mouse? And you can do this like a lot of things. And the Sorites paradox, I think, is just like a really pure version of it. It's you only vary one quantity, and that is also important. You vary a quantity, not a quality. So here we are, with other things, we're varying qualities. So like mouseness is somehow related to like making a thing pointer move on the screen. I don't know, maybe gender is related to self-identification and sex, and a lot of other things. Another one that was my first example, like in an actual philosophy class, is observability. Van Frasen and I forgot his name. I think Grover Maxwell had like a little argument about this. I think Maxwell made this point first, and Van Frasen was like, no. About what is and what isn't observable. Actually, Maxwell made the more radical claim here, because he said like, okay, I think he said there are no. Did he say everything's observable or that nothing? I think he said everything's observable. So basically, you have, you know, trees, windows, mice, things you can see. Pretty, you would say this is observable in scientific terms. Like you can do measurements on this thing, and we're pretty sure that if we're measuring this thing, we are measuring this thing, and not like, I don't know, like something that just has all the qualities of a mouse, but actually isn't. It's actually just a figment of our imagination. We're pretty sure, like, we usually want to somehow be realists about objects. You know, okay, this is a thing. And I don't mean that like in an essentialist way, like, oh no, this is a mouse. It has all the essential qualities of a mouse. No, it's just like a thing in this shape, and I can see it. I can say, okay, this is this thing. But, you know, there are some, I think you get like increasingly distant. Like I'm already a bit distant from directly observing this. I see this through my glasses. Without my glasses, I can still see it, still fine. It's more distant things. But if I do have like a thing assisting me. The other, taking one step further, looking through something through a window. You know, it's light diffracting through a window. A little less direct contact with the thing than, for instance, touching it. The like more distant step is looking through things through maybe a microscope or a telescope. Are you really Like, it's a little bit more difficult to say that you are seeing, well, like, I don't know, like, okay, well, let's do microscope. Let's just do small microscope. If we say, okay, we can just see big dust specks or something, we're like, okay, yeah, those are probably there. If we're now going further and we see microbes, then they're like, yeah, there's probably there. It's just like tiny little guys. Like, maybe like small bugs, etc. Then even smaller, we see like amoeba, single-celled organisms, etc. There's like, we can only see those through a microscope. There's no way to kind of like, I mean, there's other ways to test that they're there. That's an important part, I think, of observability, is that you have like different ways of like interacting with the thing. And then if you go even further, like if we're looking through like a DNA with a microscope, that's like, ooh, that is a lot very different kind of inference with electron microscopes, you know? They work very differently. It's not just like light being amplified and going into our eyes. It's a whole different process. And at that point, it starts to get like, what kind of observation is this? And then if you go even further and then have to say, okay, can we observe like atoms? Like you have like this video, a boy with his atom, where a boy, like I think people at IBM or something, like manipulated some gold atoms in order to like move around and make a little stop motion animation from it. Are we really seeing the atoms? Because we can't see the atoms. Also with the microscope, we cannot really see the atoms. It's like kind of their shadow. And is that kind of the same as seeing? Definitely. And it's not with photons. We are using like electric potentials and translating that into something else. It starts to get like iffier. To say like, oh, is that really is that the same kind of observability that we have here? Can we be as confident about the existence of like atoms as we are about the existence of mice? And Maxwell basically says, yeah, kinda. It's pretty continuous, and as long as we have some theories for why we would see these things, then yeah, well, we can. Because he says, like, otherwise you get this problem. There is no clear delineation point by which we could say, no, this is no longer observable. You could make one. You could say, okay, if it's no longer light immediately hitting our retina, it is no longer observable. Yeah, is that okay? So if you, instead of like looking through a telescope and seeing the Milky Way, you make like a long exposure video of it, does that no longer count as observability? I would, yeah. It's technically a very different process, because then it hits like photosensitive cells, and those cells get converted into electricity that gets converted into like bits, and that we use to display things on the screen. Very different from how our eyes process things. But if we want to give up those things, then doing science seems kind of weird, right? Like, what are we doing then if we're not really observing shit? And so he says, like, okay, there is this really continual thing. If we, like, we're all in agreement, right, gentlemen, that trees exist. Ha ha ha. Surely no one would doubt that. Well, if you look at a tree through a window, does it then still exist? Yeah, probably. Or does it still exist? It's not the question. Like, do we still observe the tree? People would say yes. If we look at the tree then through a microscope, would it still? Yeah, probably. And if you have like this continual thing, you don't have a real clear cutoff point. He says, okay, we have to pick one or the other. We have to like either say, okay, nothing is observable or everything is observable. And he, you know, wants to do science, so he says everything is observable. Yada yada yada. Electrons are tight. Then Van Fraasse comes and says, because Van Fraasse is his like philosophy is constructive empiricism. So empiricists, this is kind of a debate between empiricists and more hardcore realists. empiricists only want to deal with things that are like immediate, like sensory information, very badly explained, and are usually kind of suspect of saying that we have like the same kind of inferential like capabilities for talking about, you know, quantum phenomena as we have for mice falling or something. Oof. I'm not the one to drop it, this thing is expensive. So he says, okay, you're right, Maxwell. It is difficult to actually say at what point we stop inferring things. I agree with you, my good gentle sir, that trees are of course observable. Looking through a glass is also things are observable. Yeah. But I think he draws, I kind of forgot, and I think he draws the line a bit harder and says like, okay, if it's no longer like really observing it through with our peepers, then it doesn't count. Which, you know, that's a line. I shouldn't just randomly open Twitter. That is very dangerous. Because instead, it's just a reflex. I open it. It's so bad. What is the thing I want to look at? Not Reddit. I'm brain broken. I want to look at... Oh yeah, I want to look at this Maxwell paper. Maxwell paper observability. I think his name was Grover Maxwell. Let's see. Grover Maxwell. Yeah, that's how you spell it. I just have it in this book. Oh no, wait, my monitor is standing on the book. The ontological cells of theoretical entities, that does sound like it was that thing. Yeah, this was it. That anyone should seriously contend that the entities referred to by scientific theories are only conventional, convenient fictions, or that talk about such entities is translatable without remainder into talk about sense, contents, or everyday physical objects, or that such talk should be regarded as belonging to mere calculating device, and thus, without cognitive content, such contentions strike me as so incongruous with the scientific and rational attitude and practice that I feel this paper should turn out to be a demolition of straw men, with the instrumentalist views of outstanding physicists such as Bohr and Heisenberg are too well known to be cited, and in the recent book of great competence, Professor Ernest Nagel concluded that the opposition between the realist and the instrumentalist views of theories is a conflict over preferred modes of speech, and the question as to which of them is the correct position has only terminological interest. The phoenix, it seems, will not be later as the phoenix. Interesting. The literature on the subject is of course voluminous, and a comprehensive treatment of the problem is far beyond the scope of one essay. I shall limit myself to a number of constructive arguments and to a critical examination of some of the more crucial assumptions, that seem to have generated most of the problems in this area. How long is this paper? Yeah, it's a bit too long for like this stream now. I mean, I could do it, but it's not really. I will do that in the future. Just read the paper, but like this is not extremely relevant to what I'm doing right now. Or yeah, I mean it is. I just brought it up as a relevant idea, but it's more like this is the first time I encountered this. I don't think this is referred to as like a great treatment of the problem, nor as like a way to actually. He doesn't really make this problem known as like a specific problem. He talks about microbes, like as the thing that are real or not. The observational theoretical dichotomy is a dichotomy here. And so yeah, he reacts to it, he writes about this, and then the boy reacts to it, Professor, and says, no, cringe, I do hate theoretical entities. And so here, and at the start he quotes Nagel, Ernest Nagel. He's most well known for this book, The Structure of Science, which he also puts forth, that's relevant to my thesis, a theory of scientific reduction. So basically what it means for two theories to kind of be the same, to reduce to one another. The most famous example of this is... What is the most famous example? So the most commonly discussed example is the reduction of thermodynamics to statistical mechanics, which I also briefly mentioned in my paper, in my thesis. It turns out that it's very hard to actually define what that means, reduce to. So the basic idea is that, so we had this kind of older theory, thermodynamics, and then we have this newer theory, statistical mechanics. We like the older theory, and a lot of the predictions of that theory are true, or we can check and are useful. Thermodynamics still very useful when you just want to compute the efficiency of an engine. And statistical mechanics is way more fine-grained theory that we hope explains some underlying mechanism of the more general theory. The problem with that is you need to define what this relation is between the theory and the other. Ideally, there would be a very straightforward one-to-one mapping between the fine-grained theory and the more higher level theory, so that you could recover the predictions from the higher level theory from the lower level theory. But it turns out that's not always very hard. And in statistical mechanics and thermodynamics, there is this problem that is, for me, very relevant, which is the problem of what is the name? Taking the thermodynamic limit. Basically, you can recover these things, the predictions of thermodynamics, by assuming that the density of the statistical mechanical thing is infinite. The problem with that is it's not. And so you can say, okay, well, it doesn't really need to be infinite. It's just like if it gets denser and denser, the predictions are closer and closer, which is sort of true, but some predictions you can only make at the infinite point. And therein the problem lies. Is this reduction? Do we care? Basically that. And the answer is, people have kind of stopped caring, and people have to try to make... There are also way more problems with this reduction relation. And so in Nagel, in his book, he actually proposes this method of saying that something reduces to another, where the predictions of one theory kind of smoothly approach the predictions of another theory. But the point is that is not the case, unless you want to lose some predictive power in the higher level theory, and we don't want that. In other cases, this does work somewhat better, but not in every single case. For instance, the reduction of side note, I never know. I always get confused, like, if you say something reduces to something else, I think you need to say the bigger thing reduces to the smaller thing. But in my head, that doesn't really make sense. I always want to say it the other way around, then I think again, and I don't know, I get confused. Why is this thing different than the other thing? Which thing reduces to what? I want to say, like, statistical mechanics reduces to thermodynamics, but it's not true. I think thermodynamics reduces to statistical mechanics. And I think maybe I need to remember just like bigger thing, reduce is make less. I guess that's why I get confused. Like, it reduces in complexity to the larger thing. But that's not really how you say that. So whatever. I need to keep... So. Oh yeah, and so in other cases this does work better. For instance with classical mechanics and relativistic mechanics. There it's a lot more, I wouldn't say straightforward, but like you can recover like a lot of the predictions of statistical mechanics from relativistic mechanics, also from quantum mechanics. If you, for relativistic mechanics or special relativity, if you let the speed of light go to infinity, and from quantum mechanics if you let the Planck's constant go to 0, then the predictions usually align. But I think I haven't really looked into those very specifically. I think there are also a lot of catches there that make it a bit more difficult to say. You definitely, I don't think anyone who really is into this would say that they straightforwardly reduce to one another. I don't think it's, yeah, no, definitely not. So cool. And here, this is the note that I made. When did I make it? Let's see. 2021? No, March last year I made this note. So 1.5 years ago. Holy shit, man. I had this thought. I remember having this thought. I remember being on a walk and I thought, oh, they're similar. And then I got stuck because they are similar, but they're kind of hard to... It's kind of hard to say how they're similar. So yeah, I'm looking at infinite idealizations and this Writer's paradox, and I want to find an answer to the latter. Yeah, that's actually what I wanted to do. I no longer want to do that. It's way too fucking complicated to do that. Can you actually see view count in... Oh, I don't want cleaning and soap in my tags. Philosophy, physics. Yeah, those are the things people go to Twitch for to watch. People go to Twitch for to watch. I want to try and be better in my accent. So... yeah, let me check that real quick. Because I'm obsessed. View work count in OBS. Do you have to, how to add a Twitch viewer counter to OBS? Do I need to install, get the Twitch viewer count URL? But I don't want it on the chat. That is fucking sad. I just wanted to see it somewhere. Who is texting? Shut the fuck up. Oh, Atlassian. Shut the fuck up, Atlassian. I think Cold Turkey is still active, yeah. Schmiep, schmap. I have 3 followers. Making it big. Alright, so now I think we talked enough about these things, so I want to get back to this. So, this is indeed this thought that I had a year and a half ago. I had this thought a week ago as well, but slightly different. So, because I was looking at this guy again. So the main... So let's just read my note from a year and a half ago. My thesis heavily centers around these two topics. I want to finance the latter. I don't want to do it anymore. And looking at the form of this, and this is the reason why I'm stuck writing this. Oh yeah. Similarity. Infinite idealizations are similar to Sorites paradox because both are methodological/logical reasons for why common explanation phenomena don't immediately work out. How would we really say that? Vagueness Sorites paradox is having continuous or discrete transition from one concept/object to another, where at the one end a predicate is true and at the other a predicate is false. Yeah, and there being equally good reasons for believing that neither predicate can actually change. This is not really worded very well. And it's not obvious where the transition point lies. This leads to a paradox where either there is and isn't a transition point, or the predicate is and is not true for any point. Yeah. So for example, a man has 100,000 hairs. That's, I think, way more hairs than the average human. If he has that many hairs, then he is not bald. If a man with n hairs is not bald, a man with n-1 hairs is also not bald. That seems right. Then a man with 0 hairs is not bald. That seems weird. Like, if you have no hairs, then you're bald. That's the definition of bald. But obviously, it's not you're bald at 0 hairs. If you have 1 hair, then you're still bald. This seems false, but 1 seems true. So to fix this, we can negate 2. A man with 100,000 hairs is not bald. If a man with 2 hairs if a man with n hairs is not bald, then a man with n-1 hairs. This is basically there exists. This is basically here. It is not the case for any n that he is bald. That means there is a point at which a man with n hairs is not bald, but at n-1 hairs is bald. I think the problem with explaining this very quickly is that the conclusion of this is a negation of that, and not a negation of this. And that would be nicer. But then you have 2 premises that are unreasonable, so I guess that doesn't really make sense. So for infinite idealizations, we do not observe the fractional quantum Hall effect normally because the configuration space for the electrons is 3D. If the configuration space is 3D at n thickness / magnetic field strength, then the configuration space is 3D at n/2 thickness / 2/n magnetic field strength. We never observe the fractional quantum Hall effect because... let's make this 3. We never observe the fractional quantum Hall effect because there is... Yeah, so okay, this doesn't work because we're halving the distance. So you never get to 0 anyway. I think the problem is then... Okay, let me go take a shit and then we'll be back. Alright, we're back. We were already back, but now we actually come back. I'm just reading this paper, and he does indeed make it. He does tell a nice story about, you know, a hypothetical scientist called Jones who invented hypothetical mechanism for talking about a disease spread called crobes, who are non-observable by the time he postulates them. Like, microscopes have not been invented yet, and people having similar debates as we have now concerning electrons, etc. Then the microscope gets invented, people are able to identify these crobes and still have these debates. But some people say, oh, but they weren't unobservable in principle. That is different than how things are now. Things are now, some, strings, for instance. They are unobservable in principle. Like, I think Maxwell wrote this before string theory was a thing, so whatever. Like, they are, really stretching the fucking definition of observable. But, I don't know, I don't want to make that strong claims, but they're really small. At least 3 times the difference between, how much would be like a small bacterium be? Like a micrometer? We're like a meter? So it's 10 to the power 6 difference. So there is about the difference between a microbe and a string is there would be 5 equally distant or smaller things for the microbe. Like there's a thing that's as small to the microbe as the microbe is to us for the microbe. Then there is, for that thing, there is another thing that is as small as that thing, and that 5 times from the microbe. That's how big strings are. So it will, we need to invent 5 things as good as a microscope in order to see them. Even atoms are pretty big. Fucking huge compared to strings. I think, compared to what? The galaxy, maybe? I guess that's kind of maybe the difference of an electron to a string. So what is the galaxy? Milky Way diameter. It is, no, I don't want light years, I gotta think in light years. Mass size. How much? I know, fucking 26 kiloparsecs. 87,000 light year in meter. Okay, let's do kilometer. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4. Okay, let's copy it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. No, not close. Observable universe. I guess that's not observable. Observable quantity. Oh, no. I'm just reading aloud what I see. Oh yeah, 10 to the 26 meters. 7. Yeah, I guess probably the size difference between us and the Milky Way is the size difference between an atom and a string. Right? Atom. What is this? Atom size. Yeah, it's a bit hard to say, of course. Okay, here. 100 picometers for the... Nah, okay, 100 picometers is... That's 10 to the minus 10. Ah, that is indeed, yeah. Yeah, okay, it's a little bigger. But approximately. An ångström. Yeah, so I suppose an ångström. Okay. Enough fun. What were we doing? We were looking at this. Yeah, okay, so why are... So why is this more similar to infinite idealization to Psoriasis? I also want a thing with the Psoriasis open. Where's the Psoriatis? Psoriatis. Is this a useful way of doing it? No. This should switch with this. Because these are similar. Close isegai. Yeah. So here I say this is similar to this. Here I also say that, but in dumber words. Here I say in the big letters, the major similarity is that for both cases we do not have a mechanism for determining when this change would occur. So if the vagus paradox is a problem for baldness, then it is also a problem for this. But then I can't use this as a counter-argument. Not sure what I mean with this. I think it's in relation to Ile Sheck's paper. I can't use this as a counter-argument because it begs the question somehow. This guy is a bit in my face. I don't really know about that, but we can think it through a bit more. So what I got stuck with the normal comparison between fractional column Hall effect and the Psoriatis paradox is that with normal infinite idealizations there isn't really this transition point. There is the actual system, and then at infinity or at 0 there is the other point that you can say like, okay, well, with 0 at least you can say, okay, I take like steps of like discrete steps of a certain size down, and then you get at 0, but then you have this really big step suddenly between 0.1 millimeter, for instance, and 0 millimeters. Which doesn't really, I mean, nothing goes like this that is interesting for this thing. It's usually like, either like so, or like so to 0, oops, sorry. So, how to, and that is very different with the grain of rice stories. It's not the case that for 0 grains of rice there is no, or like the height is a better example because it's continuous. A 1 meter person is not tall, a 2 meter person is not tall, a 3 meter person is not tall, etc, etc. Only an infinitely tall person is tall. That's not the case. It is the case that like at some point, I don't know, around around 6 foot or something, you would say someone is tall or not. And that isn't the case with normal infinite idealization. Similar to taking the thermodynamic limit, like you need to have 0, like with 1 particle you can't talk about phases. With 2 particles you cannot talk about phases. With 100 particles you cannot talk about phases. With 100,000 trillion particles you can still not talk about phases in the thermodynamic sense, but with an infinite number you can. The problem I had with this though is that that is only true in like theory space, but in like meat space or normal everyday reality, obviously we can still, like, a single molecule does not exhibit phase transitions or behavior similar to what we would call a phase, like being solid or whatever. You can, like, it's a description of what a collection of things does. But with a couple quadrillion particles that you would find in like your kettle, you can talk about phase. You would say that's liquid, or it's frozen, or it's gas. It's fucking gas. And there I got kind of stuck. So there's this. You do have this. Okay, so I should make a note for this. TBH. It's a good. No. The main issue. Well, not the main issue. Problems. Two problems arise. One. Most infinite idealizations only display the limiting behavior at 0 or infinity. If its idealizations do not have a clear transition point because they only explain, And two, infinite idealizations do display limiting behavior only display limiting behavior IRL. Okay, let's say physical systems modeled by infinite idealizations do display limiting behavior at non-infinitary points. Wow. Infinitary points, yeah. Definitely a sentence that future Thomas will look at and think, yeah, that makes fucking sense. So let's make it. I want to liken psoriasis. How did you get that? Psoriasis paradox to infinite idealizations. But there's a problem. Psoriasis paradoxes have a clear point in the middle where the vagueness is. e.g. while a 1 meter person is short and a 2 meter person is tall, and we cannot really say where this transition point is. It seems to be around 180 meters. In contrast, the infinite idealization of e.g. the thermodynamic limit does not only attains infinite idealizations are a problem because they occur at a point/configuration that isn't attainable, e.g. at infinity. Let's do this. Infinity or 0. Therefore, this leads to the problem. Let's make this a note. Infinite idealizations are a bit like Sorites, but they do not have a crossing over point like the Sorites paradox has. Without it, there isn't really a paradox at all. Is it like this? Oh yeah, this doesn't work for some reason sometimes. Very annoying. Whatever. Trying to phrase the paradox. So here I want to try to create a Sorites paradox purely in the abstract thing. And to do that, I need to create two logically consistent arguments which contradict each other. If I can't do that, then, wow, there isn't really a problem, is there? I should have done this way earlier. Okay, so maybe let's try... Let's first do the induction. I think I can make this one. Let's do it with the guy. So, 1. 1 molecule of water does not display phase transition behavior. 2. If n molecules of water do not display phase transition behavior, and +1 molecules of water also do not display phase transition behavior. Probably a better way to say that, but it doesn't matter. Ergo, there does not exist a number n molecules of water that displays phase transition behavior. This is true. This is just with induction. The problem is twofold. Is that it's sort of not true because like there is an infinite number of particles that do display it. Maybe I should phrase here, there does not exist a finite number n molecules of water that displays phase transition behavior, because that's true. I think that is the same. Because if I would say this in, you know, this kind of talk, yeah. I think it's just not right. Not exists an n in math BBN such that n displays phase transition behavior. Okay, I should put quad here. Quad. I don't like that not exists, but whatever. Or equivalently, for all, I think this is maybe clearer. For all n in FEBN, it is the case that not b. Okay, maybe it is not. Okay, oh no, it's neg. Yeah. For all n in n. Yeah. And that's true. This is like, mathematically, this is true. Which is already a problem. Because in the Sorites paradox, we get a conclusion that we don't like, and therefore we do something different. Here we get a conclusion that's fine. So, what's your problem? Why don't we just say, hey, okay, why would we make the line drawing argument here? Well, that is because in the real world, this is the case. Like, problem C is true in so why do anything else? So A is, does we have no motivation to negate 2 and construct the line drawing case, and B, even if we were to construct it, it would both not contradict C, nor and it would probably be true. Oh no, it would not contradict C. Let's try. I should not use let's as much. Line drawing. And so the problem is that this starts from the other side. And so we can't really do it. But maybe, I don't think you need to start from the other side. We can also start at 1 grain of rice, like here. You can say 1 grain of rice does not make a heap. It is not the case that for all n grains of rice, n does not make a heap. And then you can still do this. So let's try. 1 molecule of water does not display phase transition behavior. Scroll down. Okay. It is not the case that for all n molecules of water and does not display phase transition behavior. So this is already not true. Unless if we get to that, so C, then we would get there is a point at which n molecules of water display phase transition behavior, but n molecules of water do not display phase transition, but n molecules, n plus 1 molecules of water do. So this is in contrast to 2. But this argument is not sound. It is valid, but it's not sound, because 2 is not true. It is, we don't have any reason to make this claim. We would make this claim if we think this is unacceptable, but it's not when looking at just the theory. So now the problem comes. So, here's the problem. 2 is simply true in thermo. Is true. Therefore, the line drawing argument is unsound. I never got why they called an argument valid when it is like just logically correct, and sound when it is like actually correct. I would use it the other way around. I would say something is sound when it is like, you know, that makes sense. But it is valid if it is also true. Like, but that's not how people use it. So, yeah, boy is wrong. Something is off. While 2 is true, is technically true, thermo. I should be more precise what I mean with 2. I'll call this 2, I'll call this 1. So this is then 1.2. It's technically true thermodynamically. In reality, it's false. Well, okay, no, I should say C. Sorry, not 2. One that C is technically true thermodynamically, in reality it is false. We do see thermodynamic phase transitions in systems of less than, or yeah, okay, that are of finite size, because everything is of finite size. Or finite size slash density. Except very maybe black. Except maybe singularities in black holes. I don't really know almost anything about that, and I don't want to make any claims about that. That to me always sounded really weird. That doesn't make any fucking sense to me. Like, why? How the hell can something be infinitely dense? Infinitely dense, it also needs to be infinitely small. Because otherwise the gravitational potential of it would be infinitely strong, obviously. And we would all get sucked into black holes all the time. Or, you know, we couldn't live because we would get killed. I don't think things can be infinitely small. So, whatever. But that is not the topic under consideration here. So, we're gonna ignore it. So something is off. So, one, it is true thermodynamically, but it is false in reality. How do we square this? What are our claims actually about? But here, this is again why I got stuck, because I don't know how to make sense of this thermodynamically. How to make sense of this? Like, yeah, so there's this. You go from infinity to some other place, but you know it doesn't really work. It's kind of fucking weird. It's really fucking, it boggles my mind. So that's why I think this ball space thing makes everything a bit clearer, because it has the same claims as the infinite idealization. Ball space and infinite idealizations. I think ball space, I should include that here. Media ball space and PNG. Is that how you do it? No, I forget how you do this. It's a link. Yeah, no, so it's, you have no content here, and then you have, yeah, and then there's an exclamation point in front or something. Media / ball space png. Yeah, let's say it. I should give it alt text, or is this a caption? No. Alt text of a picture of a sphere stuck in a, what do you call, like a rectangle, but 3D and bulk, in a, oh, what do you call that? A 3D rectangle term. Yeah, Quora, help me. A box. Yeah, stuck in a, okay, protruding out of, is that how you spell it? Protruding? Is it protruding? No, protruding. What is it? Really? Out of a box. The radius of, or no, the diameter of the sphere is larger than the height of the box. So the north and south poles are protruding from the top and bottom of the box, while the middle is fully enclosed by it. So I think ball space is a better candidate for likening an infinite idealization to Sorites paradoxes, as it displays arguably the same phenomena as the id, but has the transition point exist not on the far end of the variation axis. I guess this is a good way to phrase it. Yeah, the transition point is not on. I think for the Sorites paradox to work, you need to have the or a possible transition point on the axis of variation. Or no, you need to have the predicates be false on, or both false and true on more than one point on the axis of variation. That is also a note. For Sorites paradox requires both predicates to be true and false at multiple, requires the predicates to be true and false on multiple, requires multiple false and multiple true multiple false and multiple requires the predicate to have multiple false points and multiple true points along the axis of variation. Okay. Can we make this quickly? I don't want to close another guy, so put this here. The Sorites paradox is about a vague transition point. It's about a vague transition point existing between two conditions, to statements about something depending on a variation in quantity. E.g., when does a person start being tall between 1 meter and 2 meters? Between growing from 1 meters to 2 meters, for instance. If people were only tall at 2 meters and could never get taller than that, we wouldn't have the paradox, because there is no dispute or conflicting intuitions about where the transition point is. Similarly, if there is a clear transition point, there is no paradox. Imagine so what is something that goes between two things and has a clear transition point? I was thinking about a bathtub overflowing. This can happen either because the property is formulated separately from us forming intuitions about it, such as I'm thinking just like how people just define things in science, like, okay, this is that at this point because we just made up this point. Such as okay, when I need to think of a good thing. like a scale. Yeah, maybe the scale of Richter, you know? So just the an earthquake being a 9.0 on the Richter scale. No, maybe a better one. Catastrophic earthquake? Is that like a term? Or catastrophic tornado? Definition? And I can remember like there being a definition of like tornado definition. And I want the tornado scale definition. I can type very good. I just want to look at the Fujita scale. That sounds correct. Maybe not tornado, maybe hurricane scale. Saffir-Simpson scale. Come on, can't have someone like have like cool names instead of like F6. Okay, let's just say category 5. Okay, let's do tornado. Just a tornado being category F5 on the Fujita scale if winds of more than 590 kilometers per hour are observed. Or because there is a natural cutoff point. So as a natural cutoff point for something, like not a scale, but like maybe you getting wet, or yeah, maybe length, like just a person being too tall to fit in a certain fit to too tall to be able to pass through a door without crouching. In both these cases, there is a continuum. There are points where there are multiple points where the predicate is false and multiple points where the predicate is true, but the main contention of that there is a line to draw such that the second premise of the inductive sororities. Let's do this in math notation to be quick. Neg exists n in BBN such that neg p neg pn and p n plus 1. Okay, not and. What is the, okay, arc. Why don't they just use this? Oops. Why don't they just use an ampersand? No, it has to be, wedge. Really? I thought there was another one that's briefer. Okay, no, I'll just use wedge then. Wedge. Yeah. Thus, no paradox. Okay, it's just a good note. It's just a true statement. Gorgeous. What category am I streaming? Am I not streaming in a specific category? Science and technology. Uh-oh. Okay. So this is true. Where? In ball space. In the ball space example. Let's construct it. Ball space varieties. Ball space induction. Yeah. I did. No. I didn't make a point there. That is not true anymore. Okay, well, we'll get there. We'll get there. One. Let's say we can what do we vary? Like the height of the thickness of the plate at thickness 1. At thickness, I don't know. Okay, let's start with the thickness 0. We do the space is multiply connected, and then yeah, okay, but no. So this is also not a Sorites paradox. Let's do this. At thickness 1 kilometer, the space is simply connected if a system of thickness n does not display the thing, then the system of thickness n minus 1 millimeter also. Okay, now let's do like a really small, like a 1 picometer. Also 1 nanometer. Also does not display the thing. Ergo, there does not exist a thickness n that this is multiply connected. The problem is that 2 is just not true. That do be the problem though. Yeah, so that do be the problem. There is a system n thickness that is multiply connected. I mean, it is a little bit vague. Like obviously there is some variation there, some quantum variation, but it is clearly like, I mean, it's not very vague. It's not like with tallness, you know. It's like, man, where is this? It's like, oh yeah, it's about there. With tallness, if you would say, yeah, it's about 1 meter 80, someone would say, yeah, I don't think people at 1 meter 80 are tall. That's not even 6 foot. It's little fucking cock manlets. And when people at like, if you say 190, they say, whatever. People at 150, 85 are probably tall. If you say 185, then people are like, maybe. But there isn't any like theory to guide that decision. We don't have a theory of tallness. It's completely arbitrary what we consider tall. Just like it is completely arbitrary what we consider a heap. But it is not completely arbitrary what we consider this. So I feel like maybe my whole idea that these things are similar is just wrong. Maybe they aren't wrong. But the guy also said he was right. I mean, I feel like there is something here. And maybe I should just give up on it. Maybe I should just purely make it a physics thing and just not bother with this thing. But because what did I think here? Yeah, the problem is that the transition point is problemo. The transition point is not vague. We have theory to tell us where it is. I think the original problem is actually more Sorite-Z than the ball space one. I think the ball space is just kind of like the hurricane one. Or maybe more like, is the person able to fit underneath a door or not? It's like, yeah, if the door is 1 meter 80 high and the person is 1 meter 85, then they are not able to fit through the door without crouching. If the person is, then the transition point is at 180, and if you call the phase non-crouchiness and crouchiness, then the critical point is at 180 meters. It's just there. And you can say, wow, is there a real critical point? What's the whatever? No, it's just like, yeah. We can make experiments with this, you know, say we are fucking stupid and can't accept this, then we like have a person of 185 walk until the thing, and then we just get like a relatively continuous slide of people walk through a door, and then we measure like, okay, well, this experiment seems to show that the transition point is like at 1.79.5 with whatever, and then we have just like a door that everyone uses for this experiment. You know, we are really fucking interested in this door. Say it is maybe we discover a portal and we just want to know who is allowed through the portal, and so it turns out it's just everyone who's just shorter than the portal. Then, yeah, there's this critical point of being able to pass through the portal or not. And there's probably like this kind of edge case where if you were to eyeball a person, like, would you be able to fit through a portal? I don't know, but it doesn't have anything to do with like the infinite idealization case. There is not like, ooh, we're getting closer, like, But in a way it is similar, because I think that if this were to happen, this portal were to come into existence, and we were to make like, and we were to pretend to be like fucking idiots, and we would just like have people run into the portal and see, oh no, those don't fit, those do. Then we construct a theory of being able to fit through the portal. I think it is likely that the theory would have some kind of like infinite thing. But it is very different from the water boiling thing. It is just very different. There is no other like unless we have like a very specific theory and there is some other quantity other than like, because in comparison to the water boiling, like in water boiling, the quantity that we are talking about is temperature. Like water at normal atmospheric pressures boils at 100 degrees Celsius. That's what 100 degrees Celsius is. I don't think it is anymore, but I don't know how Celsius is defined actually. Detour? Celsius. It's crazy that this company has such good SEO that they are above the Wikipedia page for Celsius. Is this also the case for Google? Celsius. Oh my god. No, there's another company called Celsius that's better according to that. This other company is all the way here. Wow. Anyway. It is defined by absolute zero and the triple point of water. And the definition referred to the Vienna ocean standard mean ocean water, a precisely defined water standard. Yeah, okay. So it is the boiling point of water. Or it's the triple point of water, not the boiling. Is that the... No, so the boiling point is not a triple point. Okay. Okay, so it's not, it's at the 0 degrees Celsius is the way it's defined, but then at the triple point, which is there. That makes more sense than having to like pin down a certain, like say, oh yes, at 1 atmospheric pressure, that's where we define it. Then you first also need to have atmospheric pressure defined, and here if you have that triple point that is only at a certain pressure and a certain temperature, then you can use that temperature to... how is 0.01? How is it 0.01 C? If that is used to define what 0 C is. Okay. Cool. But yeah, you know, so it goes up there and then it has this phase transition. And I guess that is the thing that varies, but the thing is that it is not vague in the variation thing. It's vague in another thing, namely the amount of things. So what if we fix the variation, the parameter temperature, say we are at the triple point, and then we only vary the number of molecules, or density of molecules. Then we do get it. Then we do get the problem with, at a certain, you do see these phase transitions. I guess you can't, because there is no such thing as a phase transition at a point. If you're at the point, no transition happens. Like there's nothing. I guess what happens is that you get a phase of something, but that happens at any point, so it doesn't really matter. I guess similar for this, you can have, if you pin it at like this, whatever, you know, exactly this height, you do get this transition, you do get the quantum Hall effect, and below that you also get the quantum Hall effect. No, it's different. I think the difficulty is indeed in the... This guy is way more clear what we're varying. I think that, like the water thing, I think is way more confusing than the virtual quantum Hall effect in a way. I should add that. Where did I have? To do. Let's just like. General notes. The FQHE is in a way simpler to analyze than the thermodynamic limit, because in the thermodynamic limit you deal with two parameters that are connected in a complicated way. The temperature and the density of particles. You do not vary the density of particles when doing an experiment, you vary the temperature, but the temperature is not the thing, is not the parameter you would vary in a Sorites plus phase transitions don't really happen at a temperature. They happen over it. Bit of a weird way to phrase it, but that's kind of like the main thought. Like, people are texting me if I need to go look. Okay, I need to browse Twitter for a bit. I need to turn my brain off for a second. Do I have a browser here? No. Okay, you can look at this while I look at Twitter. This Twitter post. Just press Thomas, what are you? 96? Tweet. Someone in chat came by and very helpfully let me know that I'm a little ugly little nerd boy earlier. Very fun. This is too dangerous to do on me. Alright. So, again, I haven't gotten any closer. It still does not really resemble a Sorites in the way that I want it to. Because there isn't like... There's no... Either it doesn't resemble a Sorites because I cannot get close enough to it. Well, because the... Yeah, so either there isn't a Sorites because there is no line drawing really happening. It is either not multiply connected, multiply connected always, and only simply multiply connected at 0. Or there is line drawing, say here in ball space. Namely, when this guy is just as tall as this guy. And if that's the case, then there is also no line drawing problem. Because there is a line that is being drawn. It is there. The only other thing that you could maybe then say is that, okay, but there is, okay, I think I also thought about that last time. There is still the quantum weirdness happening there. So it is not a straight point. There is some vagueness. And I guess like in practice, those points are very close to each other. So there is still okay. So all hope is lost? Not completely. I want an extension that keeps track of I should add a tag. And get rid of... Oh, this is the title, huh? Oh yeah. Wait, am I typing this in here? No. Here. There is still this vague region in the FQHE ball space example because quantum mechanics. Maybe this is my saving grace. The only way for the FQHE ball space example to look like a Sorites paradox is to either make some bridge between theory and observation, i.e. because there is a finite length, or let's say a non-zero length at which FQHE happens, or QM weirdness at the boundary point, which could count as vagueness. Okay, so those are the options. I should also read, let's see, let's open the term. Also, fun news, there's going to be, in the coming months, a new version of Zotero will come out, Zotero 7, which will finally, after like years, use a modern version of Firefox. It will use the latest long stable, the latest stable release version of Firefox, rather than what is being used now, which is Firefox version of 5 years ago. This means that we'll be able to, at least for me, as you can see, I hear you thinking, oh Thomas, look at this nice dark extension. Oh, a dark theme. How did you do that? Well, this is an extension that I made called Zotero Night, and you can look it up on GitHub. The problem with this extension is that it is really, I cannot really develop it at the moment because the latest version of macOS does not allow you to run Zotero 60, Firefox 60, which I need to be able to inspect the DOM. There is no way, like in here, you can inspect the DOM by going like, oh, okay, there's the DOM, cool. In Zotero, because it's not a Chromium, it's not an Electron thing, that's not built in for some reason. So, it's just, yeah, you can't do it. You need to activate Zotero in debug mode and then connect another instance of Firefox with it, and then you can do that. And that kind of sucks. It sucks to do. and most importantly, I can't do it anymore. And other reasons why it sucks that like modern things like styling the scroll bars are not possible. You can't have automatic switching between day and night, like in Zotero, like in modern browsers. Yeah, it's really sucky. So, I'm very happy they also be switching to modern version. That will probably also be faster. And I'll be able to use more modern CSS rules. I don't feel like within now and the previous oldest version that many CSS. Yeah, okay, well, the scroll bar thing, that's what I want, because the scroll bar's turned on, it looks like shit. And so I have like, it only activates scroll bars when I'm scrolling, but that's not ideal. And you'll be able to write more modern JavaScript, but it doesn't really matter because it's all compiled down anyway. So yeah, I cannot use it yet because my version, my extension is one of the older overlay extensions, because that was just easier to get started with. And I need to turn it into like a proper extension. And I don't know how to do that because we'll see. I wish I could edit more of Zotero UI though. I so want this to have some more space between it, but it's just not possible. I mean, it probably is, but you'll be really fighting against Zotero in order to do it. And also, I want like this to be different. I want there to be a big title here, and then you know, everything looks the same. It's like it takes so much more effort to process things. Like this is the same size as this. This is all equally big. Like this is just a really big number. Like just like why not format this as like an actual date instead of this? Why not have the title be really big? Like that's what I care about, and then have the other information smaller. No, everything is exactly the same. It's extremely difficult to parse or anything. But yeah. What was I doing here? I was looking for. Oh yeah, the paper by. I also have it here. Let's see, because let's only do two. Ooh, can you have this? Oh, this graph analysis. It could be cool if you had like a local graph here. I also want to just have a look at the community plugins. Also, I want to just have a look at the Obsidian plugin. I think almost every worthwhile plugin also exists in this thing as it does on GitHub. I'm browsing GitHub on the side. Yeah. Speaking of which, let's make a commit, shall we? Commit. I'll change the specific message. Think about sororities in relation to infinite idealizations. That's way more than I thought. Git push. Cool. Oh yeah, let's look at the extensions again. If anyone has any suggestions, let me know. Of course you don't, because no one's here. But if you are here, mysterious stranger, let me know. Ah, there's a plugin for reading EPUBs, PDFs in Obsidian. I didn't know that. Guessing not. Oh wow. This is way better. I should just use this instead of fucking... Wow. That's impressive. I think this is way better than reading it in Zotero. Yeah. Huh. The only annoying thing is, I guess, like having this go out of sync with Zotero and having to kind of manually change it. So what if I go to, what's his name? Stevens. Structure of asymptotic idealization. I hate that I don't have access to this. Annotation target. I don't like limits. Can I make it because I know that the remark will cry if I do it like this. obviously doesn't have any highlights. Will these highlights get stored in the PDF? I don't like it about Zator that it doesn't do that. Fucking hard. Can I insert math? Post only me or only me? Okay. And if I now switch to okay, it is a bit fucky with switching. Okay, that's okay. Annotator. Now, okay. Okay. This is kind of interesting, actually. Okay, so this is not very readable. It would be cool if this, because how it showed in the fucking. Let's see, in the annotator. There's also the annotate thing there. I hate GIFs. Should have never been invented. You annotate something? That was a tag. Tags and post, and he goes back to the note. Okay, it does look good to him. Maybe I am still looking at it. No, it looks bad. Why does it look bad? Is it because of you? Oh, maybe because of nothing after it. No. Maybe he explains that, actually. data view enabled anymore? I was installed, I don't have it enabled. Does that make it look better? And I'll reload. No, it still looks like ass. Why? Oh, mine's all look like ass. Come on. Come on. Okay, what if I try it with just a new thing? Something. What is it called again? Annotation tool. Okay, I'll just use the same thing. That's for annotation target. No, still looks like shit. Still green light. How does it look different for you? That's when you're old. Sorry, this thing is sick. $131 issues. Wee. YouTube annotation is not working for you. Ah. Let's say. Oh, is this a preview mode versus non-preview mode thing? Okay, back reading mode. Oh yeah, then it looks way better. But I never do this. It's cool though. Yeah, is there any way to hide this? It's 59 degrees. I need to close some shit. It will overheat. My computer is running out of space. I do really dislike that on Mac it doesn't automatically delete damage files. Do you pronounce it like that actually? Damage files? It seems like bad. Oh yeah, download this damage file to your computer. Trust me, man. It's totally cool. Little bit more space, and still not a lot, but what was I looking for? Oh yeah. Why can't I? It's so weird. What's happening? Yeah, maybe it was GitHub's problem. this is nice. This is okay, nice. Okay, nice. Isn't there a plugin for this, like dynamically hiding something? Hide secrets. Automatically hides the sidebars. Allows you to hide files. Collapse sidebars. No. Preview. Cover editor. Image in plugin. Editor plugin. Cool. I think that is kind of deprecated. Contextual typography, code mirror options. Does it still do? Is it still? It already has all this. Okay. Nah. Hover editor, convert URL to preview. Simple embeds, multicolor markdown. Core search assistant, card preview, bigger preview. This is old. Ooh. That's nice. How long have I been streaming? I'm getting bored. 3.5 hours? Oi. Alright, okay, there's still one thing I need to do. And that is... I wanted to read over... Well, okay, maybe let's do that next time. I have to do something to do tomorrow. Where's my stream? Yeah. So let's do that next time. Alright, see ya. Bye. He says, not ending the thing.